I get up every day in my life because I'm a structural engineer. I like my job. I like doing structures. I like problem solving. And it's not just problem solving, it's being creative.
Read the Structural Engineer magazine more thoroughly.
When you ask why you're doing that, there might be a very good reason.
What training? I'd like to go into that straight away.
Why do you have a diagonal in your truss? Can you just remove it?
Oh, yes, I would love to have had all the experience I now have as a younger engineer.
I'm Visser. I'm the chair of the Southern African Regional Group, a past board member. I've served on council for almost 10 years now in various capacities, and I represent the Southern African Regional Group.
Hi, I'm David Harvey. I'm a chartered structural engineer. I've been a chartered structural engineer for most of my career, and I've worked in the United Kingdom and I've worked in Canada for the last 41 years. My role in the company is I'm a senior technical specialist in the bridge design group.
My name's Don McQuillen, and in terms of the Institution of Structural Engineers, I was the 100th president. Sadly, during COVID, that was 2020 and 21. So I'm now 2 years removed from being president, if you like. In terms of the rest of my background, I graduated from Queen's University Belfast in 1975 with a first, and I immediately went to work for a consulting practice called KMM, Kilo Mike Mike for short. The company had about 30 to 40 employees in those days, so I was part of the growth of that practice and became a partner in 1989. We grew the company to a complement of about 180 staff by the time RPS acquired us in 2004. And then more recently, RPS has been acquired by Tetra Tech. So I've been with that same company now for over 47 years in its different guises.
So hi, I'm Choon Wei. I'm the current chairman of Malaysia Regional Group, and I'm a director in RSP Engineers Malaysia. So we provide structural solutions to clients in various sectors.
Without being overly big-headed, we have to go back to the word engineer, which is actually from the Latin for ingenious. We're employed and engaged because we solve problems.
Yes.
We happen to specialize in structures, but the same thing occurs. We solve problems in structures. So I think that's really important. Now, obviously, we have to understand all the basics. We have to know how structures work, load paths, resilience, and all the aspects of building structures. But ultimately, we are just solving problems. The thing that's very common with structural engineers, we believe that we are providing a structural solution, which we are, but our clients, what we're doing is facilitating a client's ambition for a site or a structure or a building. So we're facilitating someone's ambition.
Yes.
We're not just providing calculations and deflected forms and bending moments and torsional effects. We're very much really looking to enable our clients to achieve their aspirations.
And sometimes you talk to a student that would otherwise not even think about structures.
Yes.
And you tell them what to do, because there's a lot of young people that don't understand what structures is about. What do we do? Why are we passionate as being structural engineers? Because we help somebody to build their dream.
Yes.
We help somebody to develop into something. They've got an idea, they want to build a house, they want to build a building, and that is where we get into. And that is the role that you have to play, because you open up the dreams of a person, your client that comes to you, and you help them as a structural engineer.
Yes.
That's what makes our job so interesting. When I started my career many years ago, my mentor said to me, you know what, you will never be bored one day in your life.
Yes.
Being a structural engineer, and I promise you that has been the case. It's been the truth ever since. And the interaction even with the architect or the project manager or the contractor,
Yes.
it's, for me in my career, it's not limited to only doing the design and analysis. It's actually going to site and see what you've created on a piece of paper, going through your calculations, going through the problem solving set of that, and then seeing how it develops on site, how your project grows. That is one of the very nice things that I like about the way that I've been exposed to structures and in my career. Yeah.
I absolutely agree with that. The problem solving is what it's all about, and to get to the essence of the problem solving, you have to be able to imagine. You have to understand the highway constraint, and so if you really understand the highway problem and the bridge problem, then you can solve it optimally.
Yes.
Most bridge engineering projects are multidiscipline. There's not so much single discipline work these days. It does sometimes happen. You have an existing bridge that's failed and it needs to be replaced, and there's not much of the other disciplines involved, but the vast majority of cases you're solving the problem with colleagues of other disciplines and you're trying to do it optimally. So you need to have a very good understanding of all the disciplines to do that. Yeah. Structural engineer is a born leader amongst that group, because structural engineers tend to understand their fellow disciplines better because they're knowledgeable in structural, and they should have peripheral knowledge of the other disciplines. And then you can do a very good job of completing the solution process and getting a very good answer.
Do you found any differences in engineering between the two locations you've worked at?
There's certainly differences in the markets. That's the most thing that's been most apparent. The differences in engineering are relatively minor by comparison because the fundamentals apply universally. The way in which they're delivered through a design and a design, you're designing to a design code, of course. The codes are different. The North American codes are quite different from the European-based codes. There is a coming together of codes in the last couple of decades because the North American code development, both in Canada and in the United States, has been very much aware of Eurocodes and the coverage that they've brought in, and has influenced some of the direction for the changes in North America. But it's more of a detail than making a considerable difference. And the way the markets influence it is the capabilities of the delivery systems in those markets will influence in the way you put together a design. But in Western Canada, there's a high local production of precast concrete materials, but also structural steel production is evident there. So it's well serviced by both of the primary industries. The wood market is also very well preserved, but it's not a big player in the bridge sector.
I think we can look around and see the world's major challenges are twofold. I think we have climate emergency, which everyone is now accepting of. The construction industry is naturally a very dirty industry. We create a lot of embodied carbon, we create a lot of waste. And I think as engineers, we have a really important role to design smarter, to reuse where we can, but just generally to look at what impact our structures and our buildings are having on the environment. There's also the secondary effects that we look around and we see natural and man-made disasters, and we need to make sure that our buildings and structures are robust and are fit to face whatever is thrown at them.
Yes, it's quite often that something I find quite hard, because a lot of time you go contractors all about cost and trying to explain to them some of the benefits of doing some of the things that they want to try and save money, but you got to know where to save the money in the right place. So I think it's a bit of education from our part to help.
There's a funny term which is value engineering, and the trouble is value engineering obviously often gets misinterpreted as cheapest is best. Very often it's actually about getting the best bang for your buck. It's the best structure for the input that is put into it. And just cutting costs, cutting things to the minimum required standard does not always achieve true value. You have to balance. Everything in life is a balance, and there's the two sides. There's making sure that you're not wasteful with resources, you're not over-engineering, but on the other hand, you are designing in resilience, and you're designing in a structure that can be adapted or modified or it's like everything. That's why structural engineers are important. We engineer solutions. We find the right solution for the right building or structure in the right environment.
What is probably one of the unique challenges with your local area for engineers?
I don't think there are challenges. I think it's the mindset of opening up and interacting with other people in the world. It's historically, we would have thought that we are confined to just our country. And I think many of the smaller regional groups might have that barrier or perception, but it's if you get involved within the institution, there are so many avenues. It opened up my world regarding networking, regarding the ability to get into connection with some of the best minds in structural engineering. It's been beneficial for me as a smaller company, a smaller engineering consultancy, to meet people, like I said, to be exposed to things that I would otherwise not be exposed to.
Okay, getting the right candidate. Yeah, I think getting the right people to work with within the company. Yeah, I think that's a big challenge. Some candidate come to you, they would tell you they are very interested to be a structural engineer. But a few months down the road, you find that they might not be that interested. So we have to find out what is the reason and how do we help them to overcome the situation that they are in.
Yeah, there's always unique challenges. We face a lot of British Columbia specific challenges. And one example of that is in the bridge world that I live in, there is a domination in terms of industrial bridges compared to public access bridges, which are on the road network. And so the ratio is approximately 100,000 industrial bridges to perhaps about 3,000 on the highway system. So it's very heavily industrial dominated. So one of the things you find as a bridge engineer is you're designing an awful lot for industrial loads and not for highway loading, which was much more common in the United Kingdom, for instance.
Do you think with the current rise of AI, where there's going to be a big change to structural engineering?
I think there will be a change in the analysis and computational processes, but for what I can see in the upcoming time, and we never know what the future will hold, I think there will still be a very, very firm position for a human brain to find the right solution. I think once you have a solution, once you have a concept, I think AI and computer-aided design systems will get better and better and better at analysing and sizing members and doing the computational process. But I think it will still need an engineer with a human brain
to come of that with like the unique solution. I think the best example I've heard where AI sits in is AI is really good at doing something that it knows, but it won't ever be like a Van Gogh. It won't. Before Van Gogh exists, it couldn't have done that. So we always need to come with that semi-unique solution, saying we think it's something like this, then something like AI can iterate to find the best solution out of that. Or
you can almost get to a situation where you can over-engineer the wrong solution.
Yes.
And just because the analysis is complex doesn't mean to say it's the right answer. And actually, I come back to a statement that I often make, that a good engineer makes the complex simple. Yeah. And I think the more simple we can find the solution, the better that solution tends to be. And that's where I think a human brain is, certainly at this stage of the world, far better than AI.
You drove a passion for bridge engineering. What was that passion driven from? Was it from you looking at bridges when you were younger, or just you're fascinated by the way the loads transferred through them? Or
very interesting. I was initially started in the role of designing highways when I was working in the United Kingdom from immediately post-graduation, and very quickly found that all the interaction points that were controlling the highway design were basically bridges. So all the bridge were points of constraints where you were needing to cross over or under something else, whether it be a canal or a river or a road or a ramp for an interchange. And all of those constraint points needed the bridge solution to be at least understood so that you could effectively design the highway system. And so the curiosity grew from all the problem points, which were the bridge crossings. And so I quickly wanted to solve these problems in order to solve the highway problem. And then eventually I just ended up working in the bridge area and then working closely with the highway engineering colleague who needed that information to really design the highway.
So is there any memorable projects that you worked over your career?
Many. And to single one out is very difficult. But one I'm exceptionally proud of is the Pitt River Bridge, which is something I worked on about 15 years ago. And it's heavily used currently, a 7-lane bridge. It's designed for ultimate 8 traffic lanes across one of our major crossings. And it's a triple cable plane, cable stayed bridge.
What was one of the unique design challenges with that design?
Well, we had exceptionally long piles, up to 108 meters, which we had to drive. We were required by design build contract to place our major support piles on till, which was approximately 100 meters below the ground surface. So the piles were between about 100 and 108 meters long. And that was quite a challenge getting them down. Yes. We all believed we could do it, and happily it worked out, very well because we'd have had problems otherwise.
Would you give any advice to a younger engineer wanting to get in bridge engineering?
If you are driven by bridges, absolutely you should become a bridge engineer. It's a very exciting career, and it's more than sustained me over my career, and it's still driving me to go on and do bigger and better things, and to try and learn more about bridge engineering because you never stop. And it's really exciting when you deliver your projects and you can see them immediately put to use and you can see the benefits that they're delivering. It's tremendously rewarding work and wouldn't have wanted it any other way.
What advice would you give to any young engineers?
I think looking back over my own career, it's really spend your formative early years making sure that your drivers for career moves are based on experience, not salary. 100% the salary will work itself out. Yes. And particularly as you go through your career, what's really important is you get the experience that's right for you and the work that you wish to do and the career that you wish to follow. And that experience is something that you will build on and build upon throughout your career. The other thing is to always be open to criticism and feedback. Sometimes we close our minds when someone disagrees with us. That's the wrong thing. We're engineers, we learn all the time. And the other thing is, even when you're at your early career stage, you can still help others around you. When you share knowledge and you help each other, that's when everyone grows and develops. The interaction in itself won't necessarily give you the answer, but the process of that interaction helps you zoom in and focus on where the answer should be. Yes. So it's a really good process. I think if you're not careful, you can almost be a siloed single mind, and yes, it's very difficult then to know if you're going in the right direction or not.
Yeah, because the structures, I think, more complex than what some people think, and you need multiple people to come together because sometimes you've gone down a path a long time to get to an answer. And then someone just comes over and looks over and just goes, oh no, you just do this.
And again, that's where I'm saying, let's, be open. Yes. Be open to feedback, because we've all done it. We've walked past someone or I have, I know I'm guilty as charged. I've looked over the shoulder of people and said, why are you doing that? Surely you could just do this. Yes. But actually those interactions are valuable for both parties. Because we still learn. Because actually, when you ask why you're doing that, there might be a very good reason. Yes. But again, that interaction helps both engineers come to ultimately the right decision.
I would get involved with the institution from student level on. I would take the benefits that you get, because all the benefits for students are free.
Yes.
I would get involved with young members group. I would interact. I would network and interact with like-minded individuals. Structures is such an amazing profession, and I keep on saying it, and you will see my face light up when I say it. It's the best profession in my mind, because it's so rewarding. Get involved, whether it's with your local institution, whether it's with your regional group, whether it's going international. There are no boundaries on how you get involved. It's up to you. You need to make the decision. Do I want to excel? You can decide. It's all different for any individual, depending on where you are in your phase of your life. What is your priorities for now, and where do you want to go? So there aren't limits. It's just get involved and do it.
I would suggest a review of common structural system, right? And then to have to develop the ability to identify the dominant structural behavior of that particular structural system that you are studying. The ability to sketch structural solutions, I think, is really, really important. The ability to communicate the idea to the client especially, and to other member of the design team. Yes. Conceptual design, which will lead to the more involved process of detailed design. Space requirement, space management. Everybody would be fighting for that space. Yes. The example of the walkable ceiling. So we would be having our trusses probably 6 meters high. Yes. At 60 meter span. So you wouldn't believe the amount of ducting and pipe works and firefighting requirement and the linkage bar to be installed for the walkable ceiling. The space would be packed with all kinds of things. Yes. Whether you like it or not, there is a hierarchy of things. Yes. There is a functional requirement. It needs to be this span. And therefore, I need this tall of a truss. Yes. This size of a member, and the member would be orientated, okay, option 1, option 2, option 3. And next on the list, I think preparation of drawings. Yes. Is important. And of course, after you prepare a drawing, you need to have a systematic way of checking the correctness of every line, yes, every circle in your drawing. It's tedious work, but it's very important. Yes. Online collaboration, issue tracking, visual programming, computational engineering, all these are new things. I mean, to me, it's new. Perhaps in some other part of the world, it has become norm. Yes. I think these are some of the things newer engineers should look at.
Do something that really inspires you. And I've always been inspired by bridge challenges. And so it was very clear to me when I first started work as a civil engineer, I wanted to move into bridge engineering. And so I've stayed for most of my career with bridge engineering. And so essentially all the work I've been doing is structural in my career.
Is there any lessons that you learned throughout your career that you wish you had learned earlier?
Oh yes, I would love to have had all the experience I now have as a younger engineer. But in a way, it's necessary to do it from the beginning for everyone. And it's actually very exciting unraveling or uncovering the world of bridge engineering, learning from very good mentors, which I had the good fortune to have throughout my career. That's a great start. That really, really helps you. And if you can maintain those mentors throughout your career, and by mentorship, I mean everything from advice in the beginning of your career through to a sounding board in your later career, where you use the other person to bounce ideas off and discuss problems and really find your way to the solution that you're seeking.
A lot of engineers don't like to talk about, especially when they're doing designs, but it's something that is greatly beneficial to have that open discussion and finding the right person that you can be open and honest with and have that conversation. Because even if they're just as a sounding board, a lot of the time you'll talk yourself into the answer almost.
Very true. And sometimes you go into those conversations just seeking confirmation for what you've already figured out. and very often you get it. But sometimes something else comes out that you may not necessarily have given full consideration to. And I've had one or two occasions recently where colleagues have suggested a bit of a change in direction, and I've taken it further, evaluated more, and figured out this is a good idea. This is a better way, and it does solve a lot of the issues that I thought I could solve another way. But in fact, this is a better answer. And so having good advice like that is one of the real benefits of having great colleagues or great people to talk to, even if they're not your colleagues.
Yeah. Even when you change careers, keeping in contact with those old colleagues on quite regular basis that you got along well with, just because you move on doesn't mean you need to stop that relationship.
Very true. And good people will always be good people.
Yes.
And just hang on to good people because you're going to need them.
Even though they're at that stage in their career where they're learning how to design buildings, they need to be aware of the potential dangers. And those cross reports are pretty wide in their scope as to what can go wrong with projects and materials and methodologies. And so I think it's vitally important that younger engineers keep their eyes open as to the pitfalls and the bear traps and try to avoid them. And the other thing, because I do a lot of professional reviews for different institutions, it's one of my favorite questions when candidates are applying to become a chartered engineer. And nowadays there's this huge reliance, whether it's in civil engineering or structural engineering, on software packages. And I say to them, okay, so supposing you're designing a drainage network, and you come in the morning and your laptop doesn't start up, or your software is corrupted, or something something prevents you from doing it on the computer. Explain to me how you do it by first principles. Or if they've presented me with this fabulous bit of design that's come out of a software package, I'll say, tell me how you validate that very quickly in 10 minutes.
Yes.
Yeah. And that's so important to do.
Important. Yeah, because you don't know whether it's very easy to short circuit that.
Yeah.
Because you can put garbage into a computer and
Correct.
you just get garbage out.
That's right. Okay, thank you, Brendan. Nice to have met you too.
Nice to meet you.
Good to meet you, Brendan.
Cheers.
Nice seeing you, man.
No worries.
Nice meeting you, and thanks
Good.
for the discussion.
Thank you.